Imagine a desolate red landscape, a world seemingly frozen in time billions of years ago. It's a place we've studied, theorized about, and dreamed of exploring for decades. We've sent our best robots, our most advanced instruments, all to answer one of humanity's most profound questions. Are we alone? Now imagine one of those robots, a six-wheeled scientist named Perseverance, slowly traversing an ancient riverbed. It drills into a simple-looking rock, and what it finds inside could change everything we know about our place in the cosmos. What if I told you that NASA hasn't just found another clue, but what they're calling the clearest sign of life that we've ever found on Mars? This isn't science fiction. It's a recent, groundbreaking discovery, and it's happening right now. Let's dive deep into the facts, the fascinating evidence, and what this leopard-spotted rock really means for the future of space exploration. For decades, scientists have scoured Mars for signs of water, a key ingredient for life as we know it. The Jezero crater, where Perseverance landed, was chosen precisely because it was once a massive lake. It's a perfect hunting ground for biosignatures, the subtle fingerprints that ancient life might have left behind. But the real game-changer came when the rover drilled into a rock from a formation nicknamed Bright Angel. As the instruments analyzed the core sample, they noticed something truly bizarre. Tiny, millimeter-sized spots that looked like leopard spots. On Earth, these kinds of features often form around microbial activity. The spots are a complex mix of minerals, including vivianite and greigite, and are enriched with organic carbon. The myth here is that a rock is just a rock. The reality is that this seemingly unremarkable piece of mudstone is a time capsule, preserving a chemical conversation that happened over 3 billion years ago. The surprising fact is that the mineral vivianite, a key component of these spots, can form when microbes consume organic matter and reduce iron. It's a byproduct of their metabolism. This discovery connects a specific physical feature on a Martian rock to a known biological process on Earth, making it a powerful, albeit cautious clue. So what could this mean? Could these be the fossilized byproducts of an ancient Martian ecosystem? The discovery of the leopard spots isn't just about a weird rock. It's about the context. The Bright Angel Formation is located in an ancient river valley that fed into the Jezero Lake. The mudstone itself is a testament to a long-gone, water-filled environment. The myth is that life needs a specific, perfect set of conditions to thrive. The reality is that microbes on Earth are incredibly resilient, and they often exploit complex chemical reactions for energy. The surprising fact is that the minerals and organic matter in the Chayava Falls rock sample are arranged in a way that suggests a redox reaction, a process where electrons are exchanged. On Earth, this is the very foundation of cellular metabolism. The specific combination of iron-rich minerals and organic carbon, found in a pattern that points to a specific chemical process, is a massive clue. This is why scientists are so excited. It's not just a single finding, but a confluence of clues. It's like finding a single footprint in the snow, but then also finding a discarded jacket and a half-eaten sandwich nearby. The evidence is stacking up. Could these chemical reactions frozen in time be the strongest evidence we have that life once flourished in this ancient Martian lake? Let's dig deeper into the science behind this incredible claim. Of course, scientists are the first to caution against jumping to conclusions. The myth is that finding a potential biosignature is the same as finding life itself. The reality is that geology can mimic biology in fascinating ways. The surprising fact is that the same minerals found in the leopard spots, like vivianite and greigite, can also be formed through purely non-biological processes, albeit under very specific conditions. For example, some chemical reactions involving water and certain types of rock can produce similar features. This is the central challenge of the search for extraterrestrial life. How do you prove something is biological when there's a chance it's just a weird geological quirk? NASA has a cold, caution and limitation of discovery mindset, which means they must exhaust every possible non-biological explanation before even talking about life. It's a slow, meticulous, and sometimes frustrating process, but it's essential for avoiding false alarms. The leopard spots are at the top of the list of things they can't explain away easily, which is why the discovery is so significant. The data from Perseverance alone is compelling, but it may not be enough for definitive proof. So what's the final and most crucial step in this investigation? Ultimately, The definitive answer to the question of life on Mars won't come from a robot on the planet's surface. It will come from a laboratory on Earth. The myth is that we can know everything we need to know from the rover alone. The reality is that Earth labs have a host of advanced instruments and techniques, like electron microscopes and sophisticated carbon dating, that are simply too large and complex to send to Mars. The surprising fact is that NASA's Perseverance rover has been collecting and caching these precious rock and soil samples in sealed tubes for years, creating a geological treasure hunt for a future mission. This is the goal of the Mars Sample Return campaign. But here's the rub. That mission is facing significant challenges, including budget overruns and technical hurdles. It's a multi-stage effort, with a planned launch in the near future, and a return to Earth in the mid-2030s. The fate of this groundbreaking discovery now rests on a complex, multi-billion-dollar mission. The core samples from Bright Angel, including the leopard-spotted rock, are prime targets for this return. Can we afford to wait for decades to get these samples back, or will the urgency of this discovery push the mission forward? To truly appreciate the significance of this find, we need to connect it to our own home. The myth is that Mars is a completely alien world with no parallel to Earth. The reality is that the early history of both planets was surprisingly similar. The surprising fact is that the rock sample from Mars is roughly 3.5 billion years old. Why is that number so important? Because that's about the same time we see the earliest fossilized evidence of life on Earth. So imagine a 3.5 billion-year-old Mars with lakes, rivers, and a climate that could have supported life. The Chayava Falls rock is a window into a time when both planets were young, dynamic, and potentially full of life. It helps us understand the habitability of early planetary systems. This connection is what gives the find its dramatic weight. It's a tantalizing glimpse into a shared history. Are these spots the Martian equivalent of our own planet's earliest life forms, the very ancestors of every living thing we see today? This discovery also forces us to rethink what a habitable planet really means. The myth is that life only exists on Earth-like planets with liquid water and a thick atmosphere. The reality is that life finds a way in the most unexpected and extreme environments. The surprising fact is that the minerals in the leopard-spotted rock suggest a low-temperature environment, something we didn't necessarily expect to find in the early Martian past. This hints that life could have survived and thrived in conditions previously thought to be too cold or too harsh. This expands our search parameters for life beyond Earth. It means we should look in places that are not just warm and wet, but also those with specific geological and chemical processes that can sustain microbial metabolisms. This is a game changer for astrobiology. It begs the question, if life on Mars was different from life on Earth, what would those differences look like? Beyond the scientific quest for knowledge, this discovery has profound implications for the future of human exploration. The myth is that we're going to Mars just for the adventure. The reality is that the ultimate goal is a sustainable human presence. The surprising fact is that understanding the past habitability of Mars is crucial for planning future missions. If life once existed, or still exists even in a dormant state, it poses a massive challenge for planetary protection. We can't risk contaminating Mars with Earth microbes, nor can we bring back potential Martian organisms that could pose a threat to our planet. The Mars Sample Return mission, with its strict biocontainment protocols, is designed to handle this very risk. The discovery of these biosignatures makes the mission not just a scientific priority, but a security imperative. We must know what's on Mars before we send people to live there. What kind of safeguards will we need to develop to protect both worlds? Finally, let's step back and consider the grandest question of all. The myth is that the universe is a sterile, empty void, with life existing only here, on our tiny blue marble. The reality is that the universe is vast, and the ingredients for life are everywhere. The surprising fact is that the timeline of this Martian discovery, 3.5 billion years ago, perfectly aligns with a period of intense microbial activity on Earth. It's a cosmic coincidence that's hard to ignore. This doesn't prove life on Mars, but it makes the possibility more real than ever before. It shifts the question from, is life out there, to where is it and what does it look like? The discovery of a potential biosignature on Mars brings us one step closer to understanding our place in the universe. If life could have arisen on two planets in the same solar system, What does that say about the trillions of other planets out there? Is the galaxy and the universe itself teeming with life? The search for answers continues, and you can be a part of it. If you found these facts as mind-blowing as we do, make sure to hit that subscribe button and turn on notifications. We're constantly diving into the most fascinating topics in science and history. And tell us in the comments, what do you think is the most bizarre fact you learned about the search for life on Mars? So there you have it. From a nondescript mudstone to a global revelation, the search for life on Mars has just been turned on its head. The Perseverance rover has given us the clearest sign yet, not of life itself, but of a chemical signature that is incredibly difficult to explain away. It reminds us that our universe is far more complex and surprising than we could ever imagine. This isn't just about a rock. It's about a moment in our history, a potential turning point in our understanding of life itself. What will we find when those samples finally make it home? Oh,